Okay, the curves of the spine. Starting at the very top of the spine, the occipital curve is the volume of the back of your skull. So feel the volume of the back of your skull moving backwards into space. It's a tiny movement. It doesn't even affect your neck, but it's more just feeling the fullness of the back of your head. And if that's not clear, you can try flattening it out. So see what happens if the back of your skull is flat. How does that affect your muscles and your spine? And then how does it feel to let there be volume there so that the back of your skull curves into the space behind you? The next curve is the cervical curve, which is the vertebra of the neck. So can you feel that cervical curve of your spine is a lordotic one? It's one where the vertebra will move forward in space to come underneath the middle of your skull. So when we flatten that curve out, the back of the neck gets really flat. And you can play with feeling how it is if that cervical spine flattens out. What muscles have to get active, what might engage, where tension might build up. And then what happens if you let those cervical vertebrae move forward into space at the same time that the occiput, the occipital curve, moves backwards into space. So these two curves balance each other out. Then the next curve down is the thoracic curve, which are the 12 vertebrae that the ribs are connected to. So can you feel the volume of the thoracic vertebra, that curve moving backwards in space? It's a kyphotic curve, so it has the volume of the curve to the back. And then the thoracic curve goes back, the cervical curve comes forward, the occipital curve has the fullness in the back. So now we have three curves balancing each other. The lumbar vertebra are the 5 vertebrae underneath the thoracic and above the sacrum. And those lumbar vertebrae move forward into space to support the weight of the upper body and the head. So now, can you feel the lumbar vertebra move forward, the thoracic vertebra move back, the cervical vertebra come forward, and the volume of the occiput moving back into space, all in relationship to each other. And if it's not clear how these curves affect each other, you could always flatten one out and see how the rest of your spine feels. See where tension accumulates. See what feels familiar, what feels unfamiliar. The next curve at the bottom of the spine is in the sacrum. And as adults, the bones of your sacrum are fused together, but they don't finish fusing together for several years. And as children, when we're first learning to walk, they're still not fused together. So the volume of the sacrum, the curve of the sacrum, has its volume to the back. So can you feel the sacrum kind of even translate back in space? So it's not tipping forward and back, but the volume of it moves back, even as the lumbar curve moves forward. The thoracic curve moves back. The cervical curve comes forward, and the occipital curve goes back. Now, as those curves balance each other, they each have their own relationship to the whole, and in each person, they'll balance each other differently. So the balance for one person, the degree of curvature in each curve and all together, will vary from person to person. But everybody's spine has their own kind of balance to find. And ideally, when we find this balance, we have the minimum amount of work in the muscles. It certainly takes some muscular action to stand up. But we have less effort in our muscles to hold us up, more weight falling through the bodies of the vertebrae. And with those two things, more range of movement available to the ribs as you breathe. So that moving, breathing, lifting your arms is all not challenged, not restricted by the muscular actions it might take to flatten out the curves of your spine. So once more, see if you can find the bodies of your vertebrae, transmitting the weight of your skull all the way down into your sacrum and your pelvis, through the curves of your spine. Thank you.